Welcome to Advent of Code Prep Part 3. If you don't know what Advent of Code is, it's basically a challenge that's held every year, once a year, starting December 1st, where every day a new programming challenge is released, and your score directly correlates to how many people you beat to solve that problem. I'm preparing for this year's challenges by doing the previous year's challenges, specifically 2020s, 2021s, and 2022s. If you'd like more information, check out the previous parts for more details. Now let's get into the coding. Day 3, Toboggan Trajectory. With the toboggan login problem resolved, you set off towards the airport. While travel by toboggan might be easy, it's certainly not safe. There's very minimal steering and the area is covered in trees. You'll need to see which angles will take you near the fewest trees. Due to the local geology, trees in this area will only grow on exactly integer coordinates in a grid. You make a map, your puzzle input, of the open squares dots and the trees hashtags you can see. For example, given input. These aren't the only trees, though, due to something you read about once involving arboreal genetics and biome stability. The same pattern repeats to the right many times. So you see this is the same as this, which is the same as this. You start on the open square dot in the top left corner and need to reach the bottom, below the bottommost row on your map. The toboggan can only follow a few specific slopes. You opted for a cheaper model that prefers rational numbers. Start by counting all the trees you would encounter for the slope, right 3, down 1. From your starting position in the top left, check the position that is right 3 and down 1. Then check the position that is right 3 and down 1 from there, and so on until you go past the bottom of the map. The locations you check in the above example are marked here with 0 where there was an open square and X where there was a tree. You can see 0 here and X here, 0 here, X here. In this example, traversing the map using the slope would cause you to encounter 7 trees. Starting at the top left corner of your map and following a slope of right 3 and down 1, how many trees would you encounter? You have to go right 3, down 1. 1, 2, 3, down. 1, 2, 3, down. 1, 2, 3, down. 1, 2, 3, down. Oh, I get it now. So it repeats many times. So that means this in the given line, if we go off of it, so we go right 3 and down 1, right 3 and down 1. So once we get to the end, it just repeats and goes back to the start. Okay, so what we have here is that we split the input to an array, and each array element is the string. So I think we can actually start at 1 because the first one actually doesn't matter. So we're going to the left 3 and down 1. Okay, so what we're doing here now is we have a for loop that counts the number of lines, and then within those lines, we check if the location of our pointer is equal to 31, which means it's equal to the edge. And then if it is, we repeat to 0. So that's our loop condition to go back here. And then we use that location to check if it's a tree, and we increment the counter. So if we run this, there should be 104 trees. So let's go. That's not right. Okay. Let's see. Okay, I found the issue. I think the issue was that I wasn't actually incrementing location plus 3, so it was constantly evaluating to 4 every single time. So the only thing I changed it is to a plus equals. Oh, that is wrong. Let me see. Oh, I actually found the issue. If I'm supposed to be checking if location is greater than or equal to 31. So basically the first issue I had was that location wasn't actually incrementing by 3 every time. And the second issue was that my base case was wrong because I was only checking if it was equal to 31 instead of greater than or equal to 31. So yeah, 71 should be the right answer. Oh, it's not. Oh, I know what's wrong. It's supposed to be a special case. If you hit 28, it'll be 0. If you hit 29, it'll be 1. And if you hit 30, it'll be 2. This should work because when it's 28, it's 0, 29, it's 1, and if it's 30, then it's 2. This is the correct answer. I got all the edge cases. Should be good to go. Oh my god. Oh my god. What am I doing wrong? It wasn't supposed to be going to 0 and then adding 3. When it was 28, the next increment was supposed to be 0, 29, the next location was supposed to be 1, 30, the next location was supposed to be 2. But if not, the location is supposed to increment by 3 every time. So 216 should be the right answer. If this isn't it, I don't know what to say. What the heck? I got timed out from the problem because they think I'm spamming. My time limit's up. Let's see if it's 216. Please let it be 216. Oh, let's go. Oh my God. That was way harder than it needed to be. Let's go to part 2. Part 2. Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop after all. Determine the number of trees you would encounter if, for each of the following slopes, you start at the top left corner and traverse the map all the way to the bottom. Right 1, down 1. Right 3, down 1. This is slope you already checked. Right 5, down 1. Right 7, down 1. Right 1, down 2. In above example, these slopes you'd find 2, 7, 3, 4, and 2 trees respectively multiplied together. These produce the answer 336. What do you get if you multiply together the number of trees encountered on each of the listed slopes? Oh, I get it. What the fuck? This is hard. Okay, since I solved the previous problem greedily, my solution is not going to work. I'm going to have to do something. I have to traverse this differently. Okay, so I remade the actual algorithm into a function that takes in the right and the downs. So this should be the actual answer right here. Dang it. Oh my God. What the heck? I think it's the last one that's giving it an issue because if it's +2, it's skipping over the wrong ones. Okay, I think I found the issue was that I was setting the starting value to 1 and incrementing it by the down because that's where all of them started, except when it gets down to 2, it should actually start at 2 instead of 1. This should be the answer, please. Oh, let's go. Let's go. First time I did it, I just did a straightforward greedy algorithm and I just checked for the overflow cases specifically. Then for the next solution, I did it programmatically and I checked for each of the specific slope values, the right value and the down value. And then it iterates through the correct way, showing the starting indexes right here. And it actually does the correct slope right here. It checks if it overflows right here. And then if it doesn't overflow, you just increment normally. And then we just have a normal counter. So yeah, that was Advent of Code Day 3. It shouldn't have taken this long, but you know, I'm pretty sure I'm going to say that for every challenge from here on out. If you enjoyed, like, comment, subscribe, and join the Discord if you want to talk to me more. All right, see you in the next one.